Okay, guys, we're going to talk today about graphing linear inequalities. We're going to split 3-7 into 2 days. What you need to remember here is I need to graph this, guys, in just the same way that I would graph y equals 2x minus 4. Now, when I go to finally graph it, we'll talk about this inequality and what this does here. So I'm going to start at my y-intercept, -4, 1, 2, 3, 4. Then I know my slope is 2 over 1. So I'm going to go up 2 to the right 1, or I could go down 2 to the left 1. Now, before I draw this line, we need to talk about this inequality. Okay, because it has the or equal to in here, then that means this line is going to be a solid line. So if it's less than or equal to or greater than or equal to, it's a solid line, which means this line is equal to part of the solution. If it's just less than or greater than, you'll remember we do a dotted line. Okay, and we'll see one of those before we're done here. So let's go ahead and draw the line here. I'm going to adjust my line here. Okay, so there's the line, y equals 2x minus 4. And the inequality has equal to in it. So we go ahead and make a solid line. Now, if you want to think about this, think about all the numbers that are maybe equal to something. If I said like y equals 7, you'd say, okay, well, that's just 7. If I said y is less than 7, then you could say numbers like 6 or 5 or 4 or 6.3 or negative 1.7. So when you have inequalities, guys, you actually have a lot of answers here. It's not just this line that are solutions. You've got a lot more answers here, a lot more solutions. So let's think about all of the solutions where y is less than or equal to 2x minus 4. And there's two methods to do this. The real easy method, guys, is this. Think about, since it's solved for y, think about the symbol less than. Look at this line. Where is y less than? Well, in this case, it would be underneath here. Okay, y is a vertical axis, so less than would be underneath the line. And then all you'd have to do is just go ahead and shade in your graph underneath your line. And then this would be your solution. This represents that every point that's in this shaded area would make this true. Now, I could do that by picking a point that's like 7, -2, okay, which might be somewhere around here. And I could put that point in here, so it's -2 for y. It's a 7 for x. So 2 times 7 is 14 minus 4. And 14 minus 4 is 10. Is -2 less than 10? Well, the answer to that's absolutely yes. So every point here in this shaded area would make this true, this inequality true. Every point not in here would make it false. Now that's really the other method to do this, ladies and gentlemen, which is you could just pick a point. And usually the point we try to pick is 0, 0. And then you just plug it into this inequality. So 0 less than or equal to 2 times 0 minus 4. 2 times 0 is 0. And then 0 minus 4 is -4. Is 0 less than -4? No, it's not. 0 is greater than -4. So since this point does not make that inequality true, you would shade the other side of the line, which is the same side that I have shaded. Okay, so you can do either way. You could just think, hey, less than is below the line on the y-axis. Anytime it's greater than, it's above the line, y-axis. Or you can pick a point and see if it works. If it works like this one does, you shade in that area. If it doesn't work like 0, 0, you shade in the other side of the line, which is the side I have shaded in here. Okay, let's do another one. Okay, this one, guys, we got to solve for y first here. So we're going to subtract 3x. We always want to solve for y when we're graphing. So I get negative 2y less than negative 3x minus 6. I'm going to divide everything by negative 2 to solve for y here. And I get y is greater than 3 halves x plus 3. If you notice, I divided by a negative, so I've got to make sure I switch my sign. So that is my new equation. So I'm going to start with 3, the y-intercept. My slope is 3 halves, so that's up 3, right 2, or down 3, left 2, just to give me another point here to help guide my line that I'm drawing. And this one, guys, is going to be a dotted line. Okay, this is going to be a dotted line. Why is it going to be dotted? Well, because it doesn't have the or equal to here. Okay, and guys, this is pretty simple here now. This is greater than, okay, this is greater than, which means I want to go above the line for the y-axis. So you just shade in above your line on the y-axis because it's greater than. That's it. Okay, let's look at our last example here. In fact, I have two. Both of these are pretty simple. And let's do the y first. That one's pretty simple. Y is greater than 5. Well, remember, y equals 5, guys, is just a horizontal line. It's at 5. And it's dotted because it doesn't have the or equal to. So 1, 2, 3, 4, 5. That is a dotted line there. And it's greater than, guys, so we want to go above the line here and shade that in. So that's y is greater than 5. Okay, let's do this next one, which is x is less than or equal to negative 2. Well, that, guys, is a vertical line, and it's solid because we have the or equal to, so I'm going to go to negative 2. On the x-axis, I'm going to make my line. Now, normally, you might say, whoa, Mr. Berthmar, you said it's less than, so it's above the line on the y-axis. But this one doesn't touch the y-axis. Well, here's where kind of the exception to the rule is, which is if you don't have a y, now you got to think in terms of right or left for your x. So less than is to the left. Think about your number line. And less than is to the left, greater than is to the right. So you just shade in to the left of this line, and you would be finished. Okay, guys, there you go. Here is your lesson over the first part of 3-7.